Okay, let's start seeing some problems where you wouldn't actually probably notice that it is a natural logarithm integral unless you've actually done them. So these are some trick problems. Again, some really cool problems, some really good test problems for you to see because you really just would have no clue how to do this on the test. So I'll tell you the number one, I've put this on the test numerous times. Find the integral of tangent of x dx. I cannot tell you how many people tell me the answer is secant squared of x plus c. And that is absolutely wrong. That is the derivative of tangent of x, not the antiderivative of tangent of x. So again, just test anxiety gets to people. They're like, oh my God, this is so easy. I know the derivative of tangent is secant squared, so that's what it is. No, that's the antiderivative is what we're trying to find, the antiderivative. So it is absolutely not secant squared of x plus c. So what's the trick to this problem? The trick to this problem is, if you can't do anything with the trig function that's there, change the trig function. So what is tangent of x? Tangent of x is sine of x over cosine of x, is it not? And this is with respect to x. So here's your trick. Let's let u equal the denominator. So we're going to let u equal cosine of x in this case. Step 2 again, find the derivative of both sides. So du dx, the derivative of u with respect to x. Think about what's the derivative of cosine of x. Well, that'd be negative sine of x, wouldn't it? Okay. Step 3 would be solve for dx. So dx would be du over negative sine of x. Okay. Step 4, let's rewrite that integral, making the substitutions. We always substitute in for dx, and we always substitute in for u. So when we do that, we would end up with the integral of sine of x over u, and then instead of dx, we would have du over negative sine of x. When we do that, the sine of x is simplify. I'm going to pull that negative out in front, so I'm going to have negative the integral of 1 over u du. That's easy enough to integrate, so let's go ahead and integrate. This is going to be equal to negative the natural log of the absolute value of u plus c. Again, that's easy enough as well because all we have to do is back substitute for u in this case. This would be equals negative the natural log of the absolute value of u was cosine of x plus c. So really cool problem there, a little different than what many of you probably would have thought to do with that problem. You probably didn't see that that was a u substitution problem, but man, it was. So nice cool trick on that problem. Again, I cannot tell you how many people would try to shortcut it and say the answer is secant squared of x. It absolutely isn't. That is the derivative. We are looking for the antiderivative, so you had to change this into sines and cosines. Use your u substitutions. Nice fun little problem there for you, and once you get it, it's truly not too bad. The key here is how the heck did you know how to do that? And the answer is my teacher showed me when I learned how to do it in Calc 1, and I remembered the trick, and I've remembered it ever since. Once I have trig functions, if I get stuck, I try changing them into sines and cosines, see if I can work with them from there. So how are you going to remember to do that? Practice, 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 and then when you think you're done, do some more practice. This didn't come to me overnight. I wasn't an A+ student in calculus the first time that I took it either, but the more you see it, the more you practice, the better you get at it, the better you see these kind of rules, okay? All right, so let's look at the next one right here. It says find the integral of secant of x dx. This is not an easy problem. This isn't one of those ones that I remembered to do. But let's look at this. So if it's in terms of secants and you can't do it, what's the strategy? Well, what if you changed it into 1 over cosine of x dx? What's the issue with that? Well, I know we would let u equal cosine of x. So du, we'd again have to have that derivative there, which would be negative sine of x, but there's nothing to simplify that. So this is not the right strategy on this problem. So what in the heck do? I need to multiply it by something that's a trick that's going to get the dang thing to work. So what's the trick in this problem? Here's the trick in this problem, and again, this is not one that I would have remembered. This is one that I would have had to practice a million times to do. I'm hoping not to put something this difficult on the test, but I want to show you how you can make this work because it is in our textbook. What's the trick? Well, I can always multiply something times the number 1, right? And that doesn't change it. What if I wanted to multiply this by secant x plus tangent of x? But if I do that to the top, I have to do it to the bottom as well, right? Secant x plus tangent of x. So why did I do secant x plus tangent x? Well, think about what is the derivative of secant x. Secant x tangent x, isn't it? Okay, and so I'm trying to work towards that, and you're going to see that all come together here very shortly. So what am I going to do now? I'm going to distribute that secant x across the top. When I do that, I end up with the integral of secant squared of x plus secant x tangent x. And on bottom, I just have the secant x plus tangent x. I want you to notice now, and this is all with respect to x, I want you to notice now, look at the correlation between these two functions in the numerator and the denominator. What's the derivative of secant x? It's secant x tangent x. What's the derivative of tangent x? It's secant squared x. So if I let u be the denominator, when I do my derivative of both sides, and I back substitute for dx, I'm going to get something that simplifies out with that numerator. So let's see that working. Again, this is not something I would have thought of myself. It's something that takes practice, man, it's slick, but it does work, okay? Remember, this whole thing right here is just the number 1. That's all it is. We just multiplied by this very, very clever 1. So step 1, where we're at, let's let u equal the denominator. So we're going to let u equal secant x plus tangent of x. Step 2, let's take the derivative of both sides. So that'd be du dx equals, well, the derivative of secant x is secant x tangent x. And the derivative of tangent x is secant squared of x. I'm just going to try to write this in the same format that I know it's going to simplify in. So all I did was really just swap the order of those two, which is perfectly fine. It's addition. Step 3 is solve for dx. So I'm going to have dx equals, cross multiplying, I'd have du over secant squared of x plus secant x tangent x. All right, so what do we do now? We have our dx that we need to substitute in for, and we have our u that we need to substitute in for. So step 4 is to rewrite that integral. Ooh, let me get off my highlighter real quick. Step 4 is to rewrite that integral. So I have the integral of secant squared of x plus secant x tangent x. Ooh, change the color there. All over, and then that would be a u, and then instead of dx, we have du over the secant squared of x plus secant x tangent x. Notice what happens. Secant x tangent x's are going to simplify into a 1, and I end up with the integral of 1 over u times du. Very, very friggin' clever there. Nice, nice trick. This is super easy to integrate, so this is the integral of the natural log of the absolute value of u plus c. Again, the only thing we have to do there to simplify, should have made that red, 1 second, is back substitute for u. So step 6, I'm going to go ahead and write this in the answer blank because I'm right there. This is equal to the natural log of the absolute value of u, which was secant x plus tangent of x plus c. Really, really cool, clever trick there to get our final answer. Okay, so let's look at this page again. What was the trick on the first one? First one was change it into sine and cosine and let u be the denominator, which was cosine. The second one was to multiply by this magical 1. Okay, so let me highlight both of those magic steps. So, trying to highlight. This was that magic step in the first problem, changing it into secant x cosine of x. This was that magic step in the second problem, was multiplying times this tricky 1. So those are those clear steps that if you don't know that trick, that manipulation, you'll never be able to solve that problem unless you cheat and use technology.